everyone, we're going to get started again, and I would like to welcome Gerard, who's an SQA engineer from Symantec, and he's going to be talking about scalable test selection.
All right. Am I on? All right. Thank you, Amanda. You may have to put up with a little bit of sniffling today. I have a nice virus cocktail of fun going on right now. So pardon me if it gets in the way of the talk. So as Amanda said, my name is Gerard. I'm a QA engineer with Symantec with the Security 2.0 team, which is a relatively new team that's working on some web security engines and also in the online identity space. And I'm here to talk to you today about a project that we've been working on in my team, an idea and a prototype that we created to do a little bit more intelligent test selection. First off, just some logistics. Feel free to ask questions, unless it's going to be followed by, I don't know, like a tomato to the face. But otherwise, you can save your questions to the end. I'm sure there will be time. So today we'll be talking about sort of the basic problem and a suggested solution. Suggested meaning it's going to be a high-level look at the solution with some details on how we implemented it internally, or prototyped it. Some ideas on implementation, other ways on measuring effectiveness, and some lessons learned. Also, I should preface this with saying, there's been some great talks here so far today. Most of them are relatively low level, machine and operations and whatnot. This is going to be a little bit higher up the stack. So before we start, a little bit of background. I can't assume you all know what regression testing is or what regression bugs are. So a regression bug is essentially a feature that used to work that now no longer works. And you'll see this in mature products that maybe have 20, 30 features out there. And a new release comes out, maybe a couple of the features don't work as well as they used to. This is known as a regression bug. So hence you do regression testing, which is essentially a nice cache of tests that you go out and verify that the old functionality still works correctly. The basic problem, though, is that regression tests only increase, especially on mature products. I'm sure many of you have seen this, right? As product starts out, you'll have a few tests. Maybe a new build comes out, you'll run a few automated manual tests. Eventually, though, this turns into something unmanageable, at least within a certain amount of time, right? You can't test everything all the time. So this is essentially a problem that doesn't scale well. So when you run into this situation, how do you determine what you should be testing? And another facet of the problem, a lot of times regression testing is testing all components when in reality maybe only a few are changing. So this is essentially wasted time and effort testing things that may not need to be tested. Certainly there may be dependencies between components. So if component 1 changes, you don't want to just change component 1 if there's a dependency on component 2. But I think these dependencies are things that can be learned, at least in terms of test selection. Lastly, so typically all tests are not automated. That may not be true in some projects, but I would say for the most part, that's the case. You will have some manual testing. So in time-constrained situations, reducing your manual test load becomes incredibly important. Let me give you the situation that is near and dear to my heart. Let's say you have a release that's going out Friday. No matter what happens, management has determined Friday, this thing is going out. And Thursday night, a major change goes into effect. How do you decide what to test at that point in time? You have literally hours, maybe, to test. You just do not have enough time to test everything. So how do you decide what to test? So what are you doing now, is what I ask you. I mean, I would say most likely testing as much as possible, right? Staying late. But even in that situation, you can't test everything. And you're probably going to miss things. So hopefully, there'll be a better way to select tests that you should be running. So here's the basic high-level overview of what we're trying to do. Given a set of source code changes, determine the set of tests that need to be run. Now, in order to implement this, what we've decided to do is do a little bit of data mining on some of the test artifacts that are all interrelated in testing. Things like your defect management system, the bugs that are associated with test cases and source code, your requirements, test case execution history, and build information. And from this, hopefully you'll have some sort of tool that can adequately determine what tests need to be run. This is a very non-scientific graph that is really just meant to visualize an idea. That being, your risk of releasing a regression bug back into the field is going to be much lower if you can execute every test that you have, right? But that's not realistic. You can't execute everything all the time. So we believe that if you have a better method of test selection, you can reduce your risk of releasing regression defects back into the field. If you can select the regression tests that are more likely to fail, then those failures won't be seen in the field. So the way that we've attacked this problem is to look at 3 different ways to associate source code with test cases. Source code deltas, source code changes with test cases. The first 2, requirements and defects, are a little bit more straightforward. We can make associations between the source code changes and what defects and what test cases are affected by those source code changes by doing a little bit of data mining on those 2 management tools, the requirements management and maybe the defect management tool. And then we do some more direct data mining in doing some build correlation. So here's the basic overview of how one would associate source code and test cases based on requirements. So first off, you imagine that requirements are going to be defined, probably by product managers or lead engineers, something like that. You'll have source code that's checked in to fulfill those requirements, and then test cases checked in to fulfill those requirements as well, correct? So given that, you can assume that there's going to be some sort of relationship between those 2 pieces of information, so that later on, when source code's checked in, you can say, oh, well, this source code, based on this relationship we found, most likely we should be executing these test cases, right? Because these test cases are associated with the source code through these requirements. Very similar situation with defects. Let's say in the given situation, you have a new build out, QA starts testing, and a test case fails. A defect will be created, and source code will be checked in. And from there again, you can say, well, if a test case fails and then source code's checked in to fix that failure, you probably have a relationship there, where the next time this source code is checked in, you can say, well, last time this was checked in, these test cases failed. It's probably a good idea to run these test cases again. The build correlation method starts on day 1. So build 1, day 1, and hopefully you'll have all this information saved in a database for mining when you're implementing this on build 200. You have source code changes that are checked in, and then test cases that are failed. You can make a set association from this and say, the set of source code changes that are checked in failed this set of test cases. You can continue this with successive builds, more source code check-ins, more test case failures, and more set associations. So here, source code 1 and 3 are associated with test case failures 3 and 5. So now, later on, build n, you have source code that's checked in, right? Let's hope by now that we have enough historical data to make some sort of intelligent predictions. So source code 1 and 3 are checked in. Well, based on our 2 build history, right, we can make some kind of intelligent selection. We can say, well, it looks like we should probably be running these 4 tests that have failed in the past. Source code 1 failed in both cases, those 4 tests. Source code 3 failed those 2 cases in that 1 test. So hence, the set of test cases can be selected intelligently. So now, given that the build history method is only going to be accumulating test cases over time, you probably want to put in some kind of prioritization methods. So what we've done very simple prioritization is just look at frequency. So over the build history, test case 1 has failed more times. It's probably a better test case to run in this situation. There are other prioritization techniques that you could use, weighting, recent failures, things like that. It's really up to your context, whatever it is that works best for you. This is how we view method usefulness over time. In the beginning, the requirements, as you can see, so the 3 icons here on the side are supposed to be your guide for the methods. So the requirements method at the top there is going to be useful early, because that's all you're going to have. At the very beginning, you won't have defects. You won't have many builds. And hence, that will be essentially the only one you can use at first. However, as you gain more data with more builds, more defects, we think the other 2 methods will surpass requirements significantly, especially the build correlation method. So implementation. So this is the basic metadata that we think you should probably pull in to make these set associations, to make these associations. And I don't think you should change any of the tools you're already using. You should integrate them. So for instance, bring in your change control systems, your defect tracking systems, your requirements management systems, test case management, and build system. I have to say, it is not necessarily easy to integrate all these systems together, especially if you're using third-party software or something that's not developed in-house, maybe something that's hosted somewhere else. You may not have direct programmatic access to it, which makes this obviously a more difficult problem. But if you do, the more data you have to mine, the better test selections you can make. So some very basic overview of how this would be implemented. So let's go over the requirements association implementation first. So keep in mind, we're looking for a relationship between source code checked in and test cases checked in per requirement. So an easy way to do it is to parse your requirements. Again, assuming you have programmatic access to these databases. Look for the change numbers, look for the test cases that were hopefully commented or somehow put in there to be associated with these requirements. So assuming you have the change lists or commit numbers or whatever, what have you, for your source control system, you can grab the file list associated for that requirement and say, with some amount of certainty, these test cases, 1 and 2, are associated with these 2 source files. Now, when you go back to actually use this information, let's say that data has a change. There's a source change on the parse.c file. You can look back into your tables and say, with some amount of certainty, well, these source files are associated with these test cases based on the requirements we have checked in. Hence, those are probably good test cases to run. For the defect association implementation, so again, in this case, we're looking for test case and source code associations, relationships, based on the defects that have been checked in. A good way to do this is, again, parse your defects. This is going to be very similar to your requirements. Look for the change numbers and look for the test cases that have failed. So assuming that it's hopefully in the comments or in some field that's associated with your defect, you can get the file list for that specific change or set of changes and associate, well, this test case failed with these source code changes, so there's probably some relationship. The way this will actually be used in the tool is very similar. Again, source changes will be coming in, and it will go down into that association table and say, well, according to with these source changes, what test cases do I need to run? And based on the history of your defects, it can hopefully tell you which test cases it suggests you should run. Test cases that have failed in the past that probably have a relationship with this source code. So for the build correlation method, the first thing that you probably want to do that we did is integrate with your build system so that it parses each check-in and records the changes that are being made in some table, some database that you have access to. So you can say with certainty, OK, with build X, we have 3 changes and 5 different source code changes. The next thing you'll want to do is integrate with your test case management system to get more metadata, definitely. So then you can say, again, with some certainty, on build X, we had these 3 test cases run, and 2 of them failed. So we can say with some certainty, these 2 test case failures are associated with the last set of source code changes. So how this would actually look in the tool itself is with some source code change that's checked in, you can go down and try to look at the build history and say, well, based on all of these n number of builds, with this piece of source code, how many of them have test cases that have failed? How many times have test cases failed with this source code checked in? So it looks like with these 2, we have, let's say this, for instance, there's only 2 builds that have been found with test cases 4, 5, and 6 that have failed when this source has been checked in the past. Those are probably good tests to run this time around as well. So a quick summary and comparison. So we'll look at the first 2 right now. So requirements are definitely useful early on. However, there's a main problem with management and processes that have to be in place for this to be really useful. Meaning, let's say you have test cases that are checked in. They have to somehow reference these requirements, either in the test case or in the requirement, however you do it. That may not always be the case. Not everyone does this. And at the same time, the source code, when it's checked in, has to say somewhere, somehow, this references requirement X, right? Well, that's not as easy as sending out an email and telling people to start doing it. It takes a little bit of time, change, beating people over the head, things like that. With defects, again, it's useful later on, once you have a nice set of defects that you can mine through. But very similarly to requirements, process changes are necessary. You have to have the data in the defects, which test cases failed, which source code was checked in to fix this defect. Somehow it has to be referenced within your change control system. I know a lot of times we do it when source code's checked in, it'll say within the comments, within the description, fixing defect 1, 2, 3. And in that way, we can later go on and mine all this information. The build correlation data method is much useful later on. However, it's a little bit more work. A few more systems need to be integrated, and it's going to be returning more test cases to you. So it's a little bit more error prone. It's not necessarily going to be useful method if it's returning 1,000 test cases to you, and you have an hour. Which is why you'll want to have some prioritization in there to determine which test cases to run. But it's still, at least it does narrow down the field. So our methodology is to use all 3 methods. So if we can find associations using all 3 approaches, each one will return a different set of tests for us to run. And from there, we can then determine, make another prioritization, another weighting technique to determine, OK, of the 3 methods that return tests, which test should we be running? I also have to say in our methodology, this isn't a replacement for any of our current processes. This is in addition to. So in the past, let's say when the situation comes up, when source code's checked in at the last minute, we have to determine which test to run. Maybe you'll depend on your lead engineers or managers, whoever is most familiar with this product or feature, to say, oh, here are the test cases I suggest we run, based on my own history and knowledge. So that is a great technique. It's a very useful technique. And it's good to complement that with a system such as this that also says, OK, well, also based on some historical data, maybe here's a few you missed. Here's a couple to look at as well. So in the end, for your resultant test selection tool, you want to answer the question, what tests should I run for this change? So given a change that comes in, you can use each method to get a different set of tests that it suggests. Right, so here we have 3 methods returning 3 sets of tests that it suggests. And now you have a nice set of test cases that may or may not be useful, more useful than whatever you were doing previously, probably staying late, testing as much as possible. So we've done some very simple prioritization on this tool internally on our prototype. So the first easiest, most obvious way is by frequency. Which tests have come up the most? What's failed most frequently? So we can see, it looks like test 7 in terms of frequency has come up the most. So that should probably be a higher priority than ones below it. You can also assign some simple weights. So here we've assigned some simple weights to defects and requirements and build correlations. This can be based off trust or where you are in your project. For instance, if you're early in your project, you probably are going to trust requirements. The requirements test that a little bit more because you're not going to have a lot of defect data. You're not going to have a lot of build data. So hence the tests returned by that method are probably more useful. So you can weight those accordingly. It may also be possible that you just find, just in general, for whatever reason, the defect method returns, is more consistent in returning useful tests, tests that fail, tests that show problems. And if that's the case, if you find that to be the case, then for whatever reason that's true, you can weight those accordingly. So now I want to talk about effectiveness. How do you measure a tool, such as how do you measure effectiveness? What metric would you use? Well, the first thing, we're going on the presumption that we want to run a test that's likely to fail. That's what we're looking for. This is a bit of like test philosophy, so it's debatable, certainly. A lot of people believe running 1,000 tests and having them all pass, makes you feel good, right? Things are working, hopefully, probably. And that's definitely a good philosophy to have. And we are looking for tests that are likely to fail, because it's not something that we want to re-release back into the field. So in order to track this, we're looking at using some classic sort of security lingo. I was thinking later on this, and I was thinking that's probably not security lingo, but I have more of a security background, so that's a little bit more prominent for me. So given that we want to select tests that are likely to fail, what is the worst case situation that could happen? That a test case is not selected that would have failed had it been selected. So that's our false positive, meaning that it was rejected, but it should have been accepted. Now, I want you to keep in mind that this is a false positive on the tool, not the test. If the test itself is a false positive, that's no matter to us. That's the tester's problem, whoever implemented it in the first place. We're trying to measure effectiveness of the tool itself. So if your test case is selected and did fail, true positive, that's something that was accepted that should have been accepted. And in the other two cases, the true negative and false negative, we're not so interested in because they pass. Either would have passed or did pass in the test selection. It's not data that since we're not looking for test cases that pass, that's not something we really want to track. So in this case, we want to track our false positive rate on this tool. So now in measuring effectiveness, there are a few different methods that we use, that we recommend. At first, certainly a training period, meaning you run all of your tests and compare what happened, the result, to what your tool suggested. So if you run all of your tests and test cases 1, 2, and 3 failed, and your tool just fails to return tests 1, 2, and 3, that's bad. That's a false negative. Those are tests that should have been selected but weren't, for whatever reason. So you want to put it through a training period in order to track your false positive rate. Getting back to risk, you're going to have to find a false positive rate that you're comfortable with. And I think we're going somewhere between 5 and 10% on our team. But whatever it is you're comfortable with, whatever you find to be realistic, I guess is something you're going to have to determine. We found random sampling to be very useful with the results set. So the results set right now, the tests returned are going to be directly from whatever data mining method is implemented. However, usually supplementing that with a few extra tests randomly selected, just to see what's happening, make sure that keeping you on your toes really is useful. In particular, we find that if you have a randomly sampled test that then fails, and obviously wasn't selected originally by the test, at that point it's good to stop and do a full run again of all of your tests to track your false positive rate, to sort of rerun it. And going in, sort of following on top of that, you should do regular audits, meaning every once in a while, however frequently you need to, run all of your tests, manual and automated, and track your current false positive rate. So this is, again, a nice little made-up graph to help illustrate an idea. Meaning, we believe that the risk of releasing a regression bug back into the field is going to be much lower if you can achieve a low false positive rate. So it's just something to keep in mind if you're going to implement a tool like this. Question?
Would that be also useful to intentionally inject failures in the code and see which tests actually come up?
So he asks, would it be useful to intentionally inject failures to see if the tests come up? Yes, absolutely. That'd be awesome. That's a good idea. No. Where's my pen and paper, though? I'm going to write that down. Yes, I think that'd be a great method to determine effectiveness.
I'm curious to know how you bootstrap it, because if you don't have any failure in your test at all today, and
right.
you don't make any change, your tool by definition will tell you, well, what file, I don't know what test to run.
Right. Yeah.
Have you looked at doing code coverage at all to kind of trace back basically a test to the code that is executed?
Well, first off, so let me get to the first part of that. If you have no failures, that's pretty amazing. I give you 2 thumbs up. With that in mind, you can still mine, let's say, requirements, right? The requirements method doesn't depend on test failures. It's going to look at strictly, here's a requirement, here are the test cases associated with it, here are the source code changes associated with it. So that isn't dependent upon test failures. But yes, so moving forward, have we looked at source code? So say that again. Have we looked at source code coverage?
We have like 6,000 to 7,000 test points.
Yeah.
And, they're hopefully not wholesale.
Yeah.
And we don't have the requirements.
Right. Sure.
So we start from scratch, right?
Right.
So today, I would say, assuming I'm 100% fine, I don't have the requirements, so I can see where the process starting today will help. But today, if I ask my system what test will fail if I change that file, it'll say, I have no idea.
Right.
It doesn't, you only correct with failure. My question is, if you use code coverage tool, now I can associate a file, at least with the text.
Ah, okay.
So the one that passed.
Right. So he's suggesting that using a code coverage tool, you can associate source code with tests. Absolutely. Yeah, that's a good idea. No, we're not doing that at the moment. Again, pen and paper. Maybe was there another question over here?
Yeah, I was going to point out, you want to keep track of, for every basic block, which tests execute that basic block. And since this is a conference on large data sets, that's a perfect example of a large data set. If you know your changes modify a particular set of basic blocks, those are the test cases you want to run first off.
Right.
Just by presumably your test cases cover completely all basic blocks.
Right. Yeah, so exactly. So it's suggested that if you have a basic block that changes, you want to run the test cases associated with those basic blocks that change. Right, exactly. And that's what we're trying to achieve. So just a suggested use in the beginning. So assuming that this is your basic sort of build test system, a build system that then leads into some automated or manual or both kind of testing, and then hopefully that information saved in some sort of test management system. We suggest first just integrating it directly into your build system and seeing what test cases come out. This is going to be for your initial training period, and you'll probably want to do this for a fair amount of time before you feel comfortable with using these tests normally. for the build. So sort of complementing your current system with this extra system, basically I'm suggesting you add more work on top of your current work. So getting to some lessons learned. So the prototype that we built is still relatively new, relatively young. We've implemented 2 of the 3 systems of the 3 methods, the defect and the build correlation method. And we don't have the scale of tests yet that this will be very useful for. We're in the scale of hundreds now. We're anticipating a scale of thousands, so that hopefully when we get to that point in time, a year or 2 from now, and we have thousands of tests to run, when we get to that situation when we're have an hour to test before some sort of critical security bug needs to be fixed immediately, we'll have this in place so that we can go out and see what the suggested tests are that we need to run through our thousands of tests. Process changes can be difficult. It kind of depends on your environment and atmosphere and your company. If the processes are already in place, that's awesome. If they're not, it's always a little bit harder to get those in place and to enforce them. And meaning these process changes being in particular, let's say with new defects, you have to say in the defect which test case failed. And when source code's checked in that fixes that defect, it has to say, I'm fixing this defect. If that information isn't present somewhere, it's going to be hard to detect. And again, with the same thing with requirements. When source code's checked in that fulfills requirements, it has to say somewhere, oh, I'm fulfilling requirement X, so that later on we can say, haha, now a relationship can be made. Random sampling is useful. Setting a false positive goal is useful. Otherwise, it's sort of like trying to achieve that nth degree of quality. It's impossible. You have to, at some point, find what you're comfortable with and say, well, we're at 6% false positive rate. It's not perfect, but good enough. Random sampling, I think, is very useful. Keeps you on your toes. And integrating these systems can be very difficult. If you may not have access to all the data you need, I would say work with whatever data you can get access to. Sort of schmooze the teams you need to get access to these databases if possible, and mine the data for your own usefulness. So to conclude, in those time-constrained situations, that last-minute change on Thursday night, and you have to release Friday, whether for the desktop or the web, even if it's just like an internal milestone, you can't literally test everything. It's impossible. Even if it's not time constrained, maybe it's resource constraint or a system constraint. If your build test system takes 12 hours, but you only have 6, that probably means your test system is going to have less time. So given that, you need to, we've suggested methods to help reduce your risk in these crunch time periods. And not only reduce your risk, but help save some of those human cycles. I mean, in the end, hopefully the automated tests that you have aren't taking as long as the manual tests. The manual tests are going to be much more expensive. Your human time is much more expensive than your computing time. And so what we're hoping is that you can save your human time for more important problems, like catching butterflies, for instance. With that, I conclude my formal presentation, and I am here to take any questions that you have.
You mentioned 12 hours and 6 hours. Is that the time span that you specifically were seeing where you said you've got a problem here?
No. So the question was, I suggested 12-hour build times, but we only have 6 hours to release. Is those the time periods I was working with? No, those are time periods I've heard about, though, from other companies. People come and tell me that, oh, our build test cycle takes like 16 hours, or a day, or 8 hours. And it's, ours isn't there yet. Ours is probably about 2.5 hours. But it's still a younger project, so it's only going to go up. Those things generally don't decrease.
How do you take into account an environment problem? I mean, I know, as mentioned, we are currently 8,000 tests and takes about 9 hours to run.
Right.
But not that we don't break them on our own, we do. But sometimes it's just a network issue, and suddenly half of your tests don't work.
Right. Okay.
And the Java VM version, which is not under source control, and a bunch of things suddenly break. How do you avoid that polluting your database in such a way that now
Right.
it associates the wrong thing for forever?
So the question is, how do we help, how do we work with environmental problems, things outside of your control, or outside the control of the test? Let's say someone installed a new GCC package that now is breaking all of your tests. Well, I guess in essence, I'll say that we don't. And I don't think this tool is trying to solve that problem. It has to assume at some level that the tests are correct, right? That the tests were written correctly, and that it includes environmental problems.
Well, if I change one file, right, and suddenly all my tests, right,
Okay.
because of environment, I don't want to, I want to undo the association.
Right. Okay, yeah, no, that's true. Okay, so he said we probably want to undo the association if it's breaking for a reason that's not normal, that's not a part of the test. Yeah, that's true. So I guess that's another thing in terms of, let's say, a web management console or something like that can help with these associations. There has to be a way to go and backtrack and say, oh, this association is actually false. This is a bad association to make. I mean, hopefully if you have enough data over a long period of time, you'll be able to filter that out, or at least prioritize it lower and say, well, these test cases have failed a lot more than the one random one that's failed. Hopefully those are run before the other one. Question?
It seems like this tool will be really useful for being integrated into the entire testing process, just for prioritizing what tests you run first, even if you're running an entire suite. In typical usage, do you use it when you have sort of that crunch period that you're talking about, or is this something that your developers use as part of their continual testing cycle?
So the question was, this will be useful to suggest some first set of tests to run. So is it run, so hold on, let me get this right. Is it run only by us or in the full testing cycle?
Right, it's like when you are like, we're going to run the entire battery of tests,
right.
Do you prioritize those tests with this tool?
Right now, we're still, we maintain a nice level of skepticism with this tool. So we look at the suggested tests and sort of compare them to what we're going to test and perhaps integrate them with our current tests. But it's certainly not a replacement, and it's in addition to of what we're currently doing. Yeah, but we do use it. I mean, at the very beginning, yeah. We see what it suggests, and then we run what we want, and then we also look at what it suggests.
Because you're integrating into the requirements management and code management tools, I'm just curious what tools you're using.
Right. So the question was, what tools are we using to plug into these the requirements management and defect management tools? Well,
What requirements management tools?
So that's actually, we use an internal tool that was built internally. So because of that, we have full access to it, to the database, to all the data.
So a lot of the source code that we deal with, they form a dependency chain.
Okay.
One source code here that depends on several others.
Right.
Do you take that into consideration when you select the test case that needs to be executed?
I think we're hoping that those dependencies will be learned in sort of in an underlying manner, right? If this source code change has a dependency on another source code change, but they both break the same test, hopefully that can be mined out. We aren't doing anything specifically for that situation, though. Also, I want to mention something I forgot to mention. This idea of selecting better tests to run in crunch periods is definitely becoming more and more important in this sort of moving software as a service world where release times are getting shorter and shorter. I went to a talk once by Katarina Fake, who's one of the Flickr people, and she mentioned that at one point they're releasing, they're building, testing, and releasing every half an hour. Now, that was pretty amazing. I didn't want to stand up and call shenanigans on her in the middle of the talk, but it seems pretty amazing if that's valid. All right, if there aren't any more questions, I'll be out in the hall and available if you have any more questions for me. Thank you for coming.
Thank you.